Alright guys, we're back here, we're learning about exponents. Alright, and that's what we did in class today, September 25th. It's supposed to help us and help a lot of mathematicians and scientists kind of cut down on a lot of the work that they have to do. We talked about prime factorization the other day, and some big numbers can have a prime factorization like this long. After a while, these numbers are prime. After a while, that takes a long, long time. So we're dealing with big numbers like this. They're a way to rewrite them to make a little bit more sense to us, a little bit more easier for our lives, and that's by using exponents. And a lot of times you will see numbers written in exponents and not written out this long, long way. So we have to know what they are. We talked about it today as an exponent like this. All right. And this number right here, this x, I'm going to put x, a variable in there in place of a number. That stands for any number. This is called the base. Think about it like in baseball. All right, this little guy stands on the base. All right, so this is the base. And up here, this guy, all right, is the exponent. Now, when the exponent is a 2, we say that it's squared. When it's a 3, we say cubed. Especially when we get into geometry, we're going to need to know those words squared and cubed. Right? Anything above the 2 or 3 for now, 4 through whatever, we just say to the certain power. So if it was a 4 up here, we would say x to the 4th power. Or if this was a number 2, 2 to the 4th power. All right? Let's just say it was, 2 to the 4th power. Here's my base, here's my exponent, and we talked about it in class how like this little exponent is floating up in space. It's sort of like that angel on your shoulder that's telling you what to do. If there's a cookie at home and your brother's not home and your mother promised it to your brother, there's two little guys on your shoulders, like the devil and the angel. The angel saying, eat that cookie, and the devil saying, no, not, the angel saying, don't eat that cookie, and the devil saying, yeah, eat it, no one's home. This is like the angel telling you to do the right thing. All right? This guy, the exponent, is telling the base how many times to multiply itself by. All right? It's not saying 2 times 4. Okay? 2 times 4 is 8, and that's not what the answer is going to be. What this is saying is, hey, 2, multiply yourself 4 times. So we write it 1, 2, 3, 4 times. And when we do it out, 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So 16 is much different than 8. A lot of 5th graders have fallen into the trap when they see 2 to the 4th power or 2 times. I think this is a multiplication sign in there. And there's not. All right, it's the exponent telling the base how many times to multiply itself by. All right. In general, that's what it is. This would be 3 second power or 3 squared. Here we have 6 cubed. Here we have 10 to the 9th power. All right. Now, powers of 10 we're going to get to later on in this chapter, and there's a trick about adding zeros to the end of that. I know we learned about that in 4th grade. But for now, let's stick with these guys over here. We'll do one more example. Let's think about 3 to the 3rd power. All right. So we have the exponent telling the 3 how many times to multiply itself by. What this equals is 3 times 3 times 3. We can do out the work. 3 times 3 is 9. 9 times 3 is 27. Okay, so 3 to the 3rd power equals 27. Going back to prime factorization, this long example right here, we can rewrite this to make it a lot more sense. We can say, how many 2's do we have? Well, we have a 2 and we have 3 2's. Multiply that by how many 3's do we have? Well, we have a 3 and we have 3 3's. And we have 1 5. We do not need an exponent over the top of that because it's just 1 5. All right? So this right here is the same as this down here. It's going to be the same product, but much easier to write. All right? So when we're doing prime factorization and we get, let's say, a number like 60 for a second, and we do our factor tree, and we do 10 times 6, and then 2 and 5, and then 2 and 3, here are prime numbers. We can rewrite this by saying, well, how many 2's do we have? Well, we have 2 2's. 2 2's. How many 3's? 1 3. How many 5's? 1 5's. So this is written with exponents, all right? Exponential notation. And this is the same as writing 2 times 2 times 3 times 5. A little bit shorter, makes life a little bit easier for mathematicians, scientists, students, teachers. And at base, that's what we covered today in class about exponents. Some practice questions. Answer me what this is. Find the answer to 2 to the, let's say, 5th power. Stop the video, try it now. If you put the number 10, you committed math crime. Because 2 times 5 is 10, but that's not what this is telling us to do. What this is saying is, hey, multiply yourself by yourself 5 times. So 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 would be 32. So the answer to this one is 32. All right? Maybe try this one. 2 to the 2nd power times 3 to the 2nd power. Stop the video, try it now. Figure this out. Well, 2 times 2 is 4. 3 squared, or 3 to the 2nd power, 3 times 3 is 9. And 4 times 9, well, let's do our trick here with our fingers. 1, 2, 3, 4, would be 36. So the answer to 2 to the 2nd power, 2 squared times 3 squared, would be 36. All right? Try your best. One of the things you can work on at home are pick some numbers, do factor trees, figure out the bottom and exponential note in prime factorization, and then put those in exponents. Cool, cool. Have fun studying. Thanks, guys.